This conference will now be recorded.
Hello, my name is Christine Perret, and I'm preparing this and presenting this overview of standards and open source projects for AR interoperability as part of the ISMAR Interoperability and Standards tutorial. The tutorial is given on October 4th, 2021, and is an entirely virtual event. This part of the tutorial is recorded so that those who are interested in the topic and who want to get these detailed status updates and descriptions of different projects can do so at their own time and their own speed. If you have more questions and any comments, you can certainly contact me, and I look forward to your inputs. So to start with, I track somewhere on the order of 20 to 25 different specifications, and these are spread across these 9 standards working groups that are listed on the left-hand side of the slide. I participate in some of these working groups. I also co-chair some of the groups and contribute in other ways. Now, as you can see, that's quite a lot of different specifications, and you might ask yourself, are all these really relevant to augmented reality? And the answer is yes, directly or indirectly. Well, in fact, all of these do have a direct relationship as far as my interests are concerned. And so a person could perhaps debate the point of view and come to a different conclusion. And there may be other standards working groups that I'm not familiar with also working, but these are the ones that are really familiar to me and about which I'm going to tell you. In addition to the specifications and the working groups, there are many industry associations and communities that are also working towards and advocating for interoperability. And those are on this slide. So here are just an example of 8 different industry associations or consortia that I like to hear from. I study what they are doing closely, particularly because they pertain to the industrial and enterprise use cases, which are of greatest interest to me. There may be other industry association and communities for other use cases of augmented reality. And I'm also the founder and the chair of the research committee for the AR for Enterprise Alliance, and I'm leading the program for interoperability and standards in the context of the AR for Enterprise Alliance, where I'm helping members of the Alliance develop requirements and review draft specifications. So if there are so many activities, how can we bring them all together and look at them through a single lens? Well, I'll say that it's virtually impossible for me to look at everyone's different points of view. Every company or organization needs to think through what their focus and value proposition is, and then choose their own frameworks for monitoring or contributing to these activities. Of course, if you want to contribute, you may wish to join the standards development organizations. And you can also use a framework, reference architecture, or some other model to organize these different standards groups. I like to think of these standards activities as being somewhere in a pipeline of AR experience delivery or production. So I think of things taking place in advance of the user having an AR experience, and those functions that happen during the production or delivery of that experience. And so with that in mind, I'm using here today the Ieee augmented reality reference model architecture. And as you can see across the top are the different exposures to hardware primarily, or to other resources, other external applications that interact with the real world. So world capture, user interaction. The tan blocks in the middle zone are what we think of as middleware, things that are happening very much in real time during the experience delivery. And then the turquoise bands are supporting zones or functions that include asset preparation, authoring, which may be manual or automatic, and a variety of functions in world storage that have to do with world representation and understanding the real world. And the dotted lines between these different functions represent what the Ieee AR framework calls reference points, and they're all numbered. As you can see, the upper left-hand corner starts with AR1, and the lower right-hand corner, the content export AR18. Some of these reference points are bidirectional, some of them are unidirectional, and you'd really have to study the specification as I have to fully understand it. But I'm using it here today because it allows me to divide up 3 zones. Below the dotted line on the bottom of this slide are functions that pertain to the communication, transmission, all things having to do with identification, authentication, all the user functions that we are familiar with in any IT application. And then at above the line, the dotted line, are activities, real-time and middleware and user interfaces, user interactions that are happening just as the AR experience is being delivered to the user. And then, as I said, the turquoise, 3 turquoise shapes are primarily being used in advance, but it may not be very long in advance. It may be milliseconds in advance of the experience delivery to the user. So it may be using information about the world capture in order to generate content or objects and to anchor them in the physical world. But in general, we can make these distinctions. And it's with this framework that I'm going to show you the next slide, which is not intended to actually be read. Oh, the bottom is also happening both during real-time delivery and primarily this slide is intended to show you if one were to go and start mapping individual standards development organization or even individual standards to specific reference points or to functions, those blocks that you see, you'd have a picture that looks something like this. So I think one of the things we can point out right away is in the upper left-hand corner, there's a lot of activity. There are many standards organizations and projects that are focusing up there in the world capture and in external application support. And there's also a great deal happening, let's say, in the lower right-hand part of this figure. Asset preparation, the authoring, and scene representation. All these things are the subjects of many, many standards already. And increasingly, the subjects of more activities they're being refined as we better understand what users and systems require. So with this as a sort of the background, I'd like to now dig into those standards that I feel are very closely related to augmented reality specifically, and were designed pretty much directly with augmented reality in mind, or can be used as is. So many people are familiar with the W3C. And about 4 years ago, the Immersive Web Working Group was chartered to develop something called WebXR. WebXR is a broad term that it specifies it's a group of standards, or sometimes it's called a suite of standards, supporting 3D scenes that can be rendered on hardware that's designed for VR or AR. So it's not specific to AR. There is already about 2 years ago, the release of the WebXR device API. Many companies are already using it. It's already supported in, I believe, all of the major web browsers. And it implements the core WebXR features that are on this slide here. Now, having said that, it is an active specification. It's not frozen, and we expect it to continue to evolve. Now, within the WebXR suite of standards, there is the AR Module 1.0, and this focuses on augmented reality functions. It's similar, or it basically treats AR the same way that it treats VR content in compliant browser. The main difference is it guarantees that the user's environment is visible and that the content's digitally registered, that it's being rendered in real time and registered with the physical world. Now, in the AR Module 1.0, there are these different sub-modules or activities. And what happens is that the process the W3C uses in this working group is that there is a community group, and there are these discussions in community groups among the web browser communities. And then when the topic reaches a certain level of maturity, or when the group is ready to start working on it, then the incubation repository moves into the working group itself. So from the community group to the working group, where the specification develops. And we know that at minimum, there are these that are still in some form of incubation. These sub-modules, the anchors, computer vision, and so on and so forth. And those will continue to evolve until they can become a candidate recommendation. There are 3 that are moving ahead well at this time. I'd say even depth sensing is the most active, but we have depth sensing is available and is beginning to be tested and implemented in a test ways, and as well as lighting estimation and real world geometry. These specifications, they're not specifications, they're just parts of the AR Module 1.0 that are, I would say, rather slowly and carefully advancing towards being specifications. So you can learn more about those at the links there. The W3C also started, I believe it's in 2018, the Web of Things working group. So again, it's a suite of, it's producing a suite of standards, the first of which was the Web of Things architecture that describes this framework, which is in this figure, and then the Web of Thing description that is to the IoT what index HTML is to a website. It's the starting point, the entry point. I attend currently the use cases and requirements. There's, I think, 7 different working groups, sub-working groups within the Web of Things, and I attend the use cases and requirements, and the discovery working group. And those 2, I know, are very much thinking about augmented reality use cases and the discovery of augmented reality, or at least understanding where a thing is in the physical world in order to use it for augmented reality experiences. So these are, I consider, quite active at this time and something to be watched closely. The devices and sensors are sometimes called the DAS working group, has been around, I think, 6 or 7 years, and defined the W3C generic sensor model. The generic sensor model has many submodels, and the W3C geolocation sensors extends that framework to provide geolocation of the device. So the editor's draft is quite current. Again, it's something that is in progress and considered to be very mature, but still relevant for refinements. And as you can see on this slide, there are several different ways of obtaining location, the geolocation, and each technology adds a level of certainty. Those are the three main activities within the W3C. Now I'm going to turn to the Kronos group standards for XR. Now, Kronos group does a very nice job of separating the standards activities in 4 domains. The input and output, so the left and right of this picture, and the specifications or the APIs that are specifically for hardware, such as head-mounted displays, the bottom, the OpenXR specification, and at the top, the specifications that pertain to 3D assets. And of course, a lot of augmented reality needs and will benefit from having 3D assets. OpenXR is the most specific specification within the Kronos group. It gives access to device runtime hardware specifically, and this allows content portability across a wide range of devices, as you see in the middle here. So it creates an abstraction layer and an API so that those XR experiences and the people who are doing coding and developing content and the application layers don't need to know the details of the hardware. So this gives them cross-platform and high-performance access to any device that supports the OpenXR specification. And it is getting a great deal of traction, so it's widely adopted at this time. It's also an active working group, and there's always changes to the repo and discussions among the members. Now, OpenXR is working in combination with a 3D API, any 3D API, including another one by the Kronos, defined in the Kronos group, and that is the Vulkan specification. So OpenXR can also use other 3D APIs like Direct3D or OpenGL or OpenGLES. But where Vulkan is available, the applications will get the most speed and the best performance available. And that's not performance, for example, for the development of geospatial content. It's really at the time of the display when the digital content is being rendered and it's being it's tracking the real world. So and also the interaction. So there's a lot having to do with haptics, there's gestures and other forms of interaction that benefit from the real-time acceleration. Another very, very important and mature Kronos group specification is GLTF. GLTF is to 3D assets what JPEG is to images. And so you've probably heard about GLTF. It's been available now already for 6 years, and it's been coming along quite a lot, and it's very, very widely used for the content transmission. So as I said, it's been around since 2015. It's been supported in many different platforms and tool chains. And in the last 12 months, there's been a lot of extensions to improve the performance, but also to improve the realism of the assets. And in the last 6 months of 2021, or the March to September, there's been a series of meetings about GLTF for AR. There's been also workshops in conjunction with the MPEG and other, the 3GPP community, to talk about extensions to GLTF for immersive experiences. So this is an extremely large and active group, meeting many times a month, and there are subgroups focusing in asynchronous mode as well. I mentioned that there have been some recent extensions to GLTF. Again, these are primarily to improve the rendering and the quality of the assets that are transmitted, and to make it available to as many tool chains, in as many tool chains as possible. So just want to make sure you understand. You'll see GLTF very widely supported, and it is important for augmented reality assets. Another Kronos group activity is the 3D Commerce Working Group. 3D Commerce Working Group is doing not specifications in a conventional way, but they're definitely developing a suite of support tools to help those who are developing and designing 3D assets get them into a 3D window for the user. So the deliverables for the 3D Commerce Working Group include asset creation guidelines, product configurators, a lot of different kinds of metadata, structured metadata, to make sure that through the pipeline, as this asset moves through either AR visualization or for the purchase of a product, that there's always a way to see the very same asset, that it never changes or deteriorates as it's moving through these different phases of 3D commerce. In addition, since March 2021, there's been an exploratory group around camera APIs. I keep this image to tell you about how the Kronos group has collaborated with the Embedded Mobile Vision Alliance to make this exploratory group very inclusive. And over the course of 6 months, there's been a fantastic amount of collaboration and contribution during the exploratory group phase, and they are now at the point of developing the scope of work documents, and that's going to bear fruit in the very near future. And then work would presumably begin in the best place possible. So those were all of the updates I can give you about activities in the Kronos group. There's much, much more going on in both W3C and Kronos group. But now I'd like to talk to you for a few minutes about the many working groups and activities in the Open Geospatial Consortium. In my mind, this is equally important, not focusing on the graphics or the web browser itself, but there's a lot of support for web technologies in the Open Geospatial Consortium. So I split the activities in the OGC to the highly relevant and the somewhat relevant. These are on the right-hand side, very important, but they're not directly talking about augmented reality as a use case in all those cases. So on the left-hand side, Geopose is a new specification, is currently in draft, but in general is telling you that a pose, which is the combination of position and orientation, has an associated frame transform chain, and using these transform chains in association with frames, then the fixed pose can be put on the Earth. And when that fixed pose is related to the Earth, it's called a geopose. It's a series of so it's a data encoding, and it says that geopose ties the location and orientation of any spatial object, whether it's physical or digital, to the planet. And this is really many use cases, including augmented reality. There are use cases for drones, for autonomous vehicles, robotics, for simulation and reconstruction. It's a very wide set of use cases. We've been working on this specification for more than 2 years. The draft was made public in February of 2021. on GitHub. There were screen movies. We are constantly recording new updates, but basically things haven't changed a great deal since the beginning of 2021. And that's why about 3 weeks ago, the Geopose Standard Working Group asked the OGC Architecture Board to review it, which it did, and approved that draft for public comment. So that'll be released in the coming weeks. In parallel, we're preparing guides and a website about Geopose. So another OGC standard is called Indoor Mapping Data Format. This is a community standard, and what that means, it was contributed by an organization, in this case, Apple Computer, and it became an OGC standard. It defines a comprehensive model using GeoJSON for any indoor location. So you can understand why that's very valuable for augmented reality. It's the basis for orientation, navigation, and discovery of information and places indoors. So a feature object can be a physical or conceptual element of anything in an indoor map. And earlier this year, February 2021, it was published as an OGC standard, and it can be rendered in a wide variety of operating systems, devices, and browsers. A point of interest is a location for which there's information available. Now that's pretty general, and in fact, that's why it's so powerful. It, of course, could be relevant for augmented reality, but as well as many, many other use cases in which people are consuming or publishing information about a location, about a point of interest. It can be as simple as a XY coordinate. It could be the name. It could have variables. It could be a 3D model. And the curious thing is there's not a standard, there never has been a standard for points of interest. Every single company that needs to generate points of interest data or to consume it must have its own proprietary format. But the work on a POI standard started 10 years ago in the W3C, and it was briefly moved to the OGC, but the work did not continue. So in the beginning or late 2020, myself and a few other people decided it was time to dust this off and to recharter the Points of Interest Standards Working Group in the OGC. That new charter was approved in March 2021, and we are meeting monthly. We are working in the open. So if you want to go and visit the Points of Interest GitHub repo, you can do that and learn more. We are still working on requirements. So there is some background work that must be done, but it's very exciting work nevertheless. The British Standards Institute has a mirror of ISO IEC JTC1 Subcommittee 24, of which it is chair, the BSI, and they've started a new working group on health, safety, security, and usability in AR and VR. So in 2021, the working group 11 was formed and has begun working on 2 specifications, the AR/VR cleanliness requirements and AR/VR health and safety specification. Just at the beginning of that work, and there are meetings regularly scheduled of the BSI, as well as the SC24 Working Group 11. Another specification that is highly relevant and has been under development for a few years now is the ETSI Industry Specification Group AR Framework. So this work began in 2018 or late 2017. And in March 2020, the reference architecture for Runtime AR Engine was published as Group Specification 003. It is public, available, and you can get it off of the ETSI ISG AR Framework web page. This is the figure that I showed you at the beginning of this presentation. And this is a very, very valuable figure and specification because it describes functional reference architecture that can be applied in many, many different ways. What has this group been up to? Well, over the course of 20 So in the scene management, in this upper left-hand corner, the Ieee ISG ARF working group developed the requirements for interoperability. And I was the rapporteur for that. I guess I could say I still am the rapporteur for this work. The working group approved it in September 2021, and it will be released for public comment later this month, October 2021. So be looking for that. Now, the Ieee ISG ARF is starting a different approach, and this is going to be discussed in another part of the ISMAR tutorial. One of the approaches that standards development groups can use is to develop an open source implementation and then to describe that in a standard. So it's called an implementation-driven standards development process. There are other parallel activities that we could describe. There's model-driven standards development as well. And I think this is a very exciting approach that the industry specification group is taking with the support of Ieee. Now let's turn to the new activities or the existing activities in the ISO IEC Joint Technical Committee 1, Subcommittee 24. Subcommittee 24 has a working group 8 for the spatial reference model, working group 9 for the AR continuum concepts and reference model, as well as working group 11, which is the one I mentioned earlier, started recently in 2021 to focus on health and safety. So the working group 9 has been steadily developing its portfolio of specification around mixed and augmented reality. There's an architecture and several other specifications such as representation of objects when rendering, and also material properties and parameter representations in haptics. I believe at this time there are 5 different specifications currently active in this working group, and you can go to the tutorial webpage on standards and access these pages from the links I've provided there. In addition to the Subcommittee 24, which is focused on graphics, there's another subcommittee in ISO JTC1, ISO IEC JTC1 Subcommittee 29 is the MPEG working group. And Within this, there are quite a lot of different specifications. Just want to take a minute to introduce to you the Internet of Media Things, IOMT. They have already released and defined their basic architecture, which defines entities and M things, as well as APIs between entities and M things and between M things to control and communicate. Over the last 6 months, so a large part of 2021, this working group is also defining other interfaces that will interact with control systems that are industry specific or domain specific, sometimes we say. So they are defining more interfaces and control and command monitoring interfaces that are very exciting to integrate the media things into existing automation systems. MPEG also has a very big community of active members working in the MPEG-I, or what they also call MPEG Immersive Video Working Group. So I encourage you to go and learn more about that. It is a lot about VR, but they're also working on some components that could be relevant for AR. There's also MPEG-V, which dates back to the, I think, 2015 or 2016, and it describes how digital worlds can be shaped and reflect the real world, and how the real world, and vice versa. So there are some still relevant components in MPEG-V, and increasingly some specifications within the MPEG-I suite of specs that could be interesting for augmented reality, especially as there's a close relationship between the MPEG working group and the 3GPP, which defines 5G. So because of that tight relationship, I'm going to tell you next about the 3GPP work on 5G and extended reality, which includes augmented reality. So the work started 3 years ago with the development in the interest group, or the specification group activity 4, which is content formats and codecs. And they defined this very general functional architecture for how XR could work into a 5G system. But about for the last 12 months, actually, since fall 2020, and it's very active at this time, there's the work on a technical report, which is a precursor to a standard. The technical report 26998 is on the subject of 5G glasses for mixed and augmented reality on 5G networks. It is not yet a technical, it isn't a technical specification. It's not a group specification. It won't become one, but it's the basis for specifications in the future. And so this is already in version 1.0, and it's coming up to perhaps being finalized as early as the end of this year, 2021. So it defines several different architectures for devices. As you can see, there's a standalone augmented reality system. There's also the star-based immersive surface architecture. And there's another one called Edgar, which uses the edge to process different media and provide those to the augmented reality glasses. That's the status of augmented reality activity in 3GPP and MPEG. I'm now going to turn my attention to the IEEE Standards Association. So the IEEE is a very, very large standards association, has many different committees and working groups. And last fall, or about a year ago, a new working group was approved, and it started in July of 2021. The P2874 Spatial Web Working Group. And as you can see on this screen, the Spatial Web Working Group is focused on a protocol and architecture and governance. So this is really interesting because it's bridging both the functional specifications that will define really technical components, as well as things pertaining to ethics and regulations and contracts. So as you can see, the project will include the hyperspace transaction, or will define the hyperspace transaction protocol, which is going to then include a spatial range query format, a semantic data ontology schema, a verifiable and credentialing and certification method, and a human and machine readable contracting language. So this is a very, very wide scope, and this work is being done with the IEEE in conjunction with the Spatial Web Foundation. So the Spatial Web Foundation is dedicated to the promotion and the development of these protocols and the ecosystem that should emerge based on that protocol. We're currently, and I say we because I'm a member of the working group's leadership, I am serving there, and we're defining the requirements and use cases in preparation for discussing the full protocol. Very exciting group, and I hope that you'll learn more about that in the future. I'm also active in the IEEE AR Learning Experience Model Working Group, ARLM. P1589 was published in April 2020. So there is material, there is information out there about it, and there's an open source implementation, which I'll tell you more about in just a minute, that is available. Now, I must say, the IEEE ARLM working group is focusing primarily, and it's sponsored by the Learning Technology Subcommittee. So that means the use cases include augmented reality in any context, but the focus is on learning and education. There's also the IEEE Standards Association VR/AR working group, established around the same time, maybe a little bit after the ARLM working group. And it is a family of standards. There are 12 at this time. There are, my understanding is that the work on the fifth component, the fifth part on safety, is coming along. And it's interesting because you see safety coming up in multiple places. You'll see it again in another specification that's being worked on in Underwriters Lab, UL 8400. So safety is clearly an important consideration in many standards groups as well as communities of adopters. The IEEE SA also has another working group on AR on mobile devices, and this is much more recent, only a year into its life, and this working group has already delivered a draft specification, the P2048.101, and it specifies this technical framework. It describes components and processes of an AR system on a mobile device. It's not just for smartphones. It's also could apply to glasses, and it defines the requirements. It's really, really important. You can see that it's defining different types of requirements, functional requirements, performance requirements, safety, and methods to test compliance. Very interesting, and I'm excited to participate in this process and the development of this specification. I mentioned a few minutes ago that safety is an important consideration, and so I mentioned the Underwriters Lab. There is a standard technical committee call for 8400, UL 8400, and it's composed of the equipment manufacturers and the component manufacturers for AR and VR equipment. Very interesting work. In part, it's working very quickly, very rapidly. It started in 2019, and already in middle of 2021, there have been many sections of it that are stable. And the reason that it's working so quickly and so effectively is that it's partly based on the technical requirements of another UL standard that was for risks of electrical and fire hazards in equipment for communications and technology. So they already had a foundation. That's a really a key thing. In the most recent meeting, just a month ago, there were 3 task forces that were established to focus on these 3 topics: the software providers, an annex for software providers, some terms and language for warnings that would appear in the view of the user or on the device or on the packaging, and also information about vulnerable age groups, particularly the young people. So they'll be looking at how to assess risk, how to measure that, and then what kinds of hazards they need to measure and to control for. It's very, very important work because of the strong participation of the hardware manufacturers. Seems all of the manufacturers are involved, very committed, and good work there. So that ends my wrap-up, general roundup of all the different standards that I work on and that I'm aware of over the course of the year. And now I'm just going to introduce a few open source projects that I'm aware of, and I want to encourage you to examine more closely. The 3 I'm going to talk about are Mirage, Solar, and STAC. So the mixed reality augmented environments comes from the same group that worked on the ARLM specification. That's the IEEE 1859. It uses the same concepts as the Web of Things, but now it's the Web of Augmented Things. And it's being worked on. Mirage is an open source implementation, and so that's available on GitHub, and you should look at that and download the different libraries and attempt to compile those and make your own example applications. Another open source project has completely different purpose, and it is focusing on computer vision pipeline targeting AR. For example, the computer vision pipeline for camera pose estimation or 3D mapping. And it provides interfaces so that if they're implemented, they can be used in reused in applications, and developers don't have to start from scratch. There's also a suite of computer vision components that are open source, and there are plugins for third-party applications such as Unity. It is available on GitHub, and it's very well documented. It has its own website, and it is an active project. Just recently as August 2021, there was another release of the open source library, so I do hope you'll check that out. Also, I want to tell you and encourage you to visit the website and information about STAC. It stands for Spatiotemporal Asset Catalog Specification. And as you can see, the purpose is to provide a common language to describe a range of geospatial information. Sounds like reality, and which contains a lot of geospatial information, and it's a way to expose collections. So it's going to be very valuable for discovery of information in the real world. So all of these topics that I've covered today in this presentation are available. There are links to all of those projects, especially the standards and the different standards working groups and the different specifications. If you just go to the tutorial for this website, there is a dedicated page for standards. I encourage you to go there for more and to contact me if you have any questions. I look forward to your feedback and to working with you for more interoperable standards, interoperability standards, and the adoption of those standards. I do hope you'll take the time to watch and listen to the other segments of this tutorial. Thank you very much.